Learn it fast, learn it smart, learn with us at SOFO. Subscribe now for more videos. Contact us for on-demand and regular tuition classes.
Welcome to Concept Videos from SOFO Learning. Today we will review the distance formula in the XY coordinate system of axis. So let's refresh our memories around what is the XY coordinate system. Alright, so it contains three things. One is the origin, second is the x-axis, and similarly third is the y-axis. Now typically we say the horizontal axis is the x-axis and the vertical axis is the y-axis. And this point where both axes meet is called origin. Right? Now we can represent any point in this coordinate system using its distance to the x-axis and to the y-axis, to the straight line distance to the x-axis and y-axis. Let me kind of demonstrate that to you. So let's pick a point here. So the distance or from the origin is governed by this line right here, this straight line to this point. All right. Now, how do we think about, how can we easily find this point? We can just draw a straight line parallel to the x-axis and a straight line parallel to the y-axis. Well, let me just use a different color here. So this and this. All right. Now the distance along x-axis is called the x-coordinate. All right. So this distance is the x-coordinate and this distance is called the y-coordinate. Remember, this is basically a rectangle because this is a straight line, this is a straight line, and this is 90 degrees, this is 90 degrees, this is obviously 90 degrees because the axes are always 90 degrees with each other. So all angles are 90 degrees. So this is a rectangle and this diagonal forms a right triangle right here. All right. Now the distance along the x-axis is called x-coordinate. Another way to think about it is the distance to the y-axis is the x-coordinate. And similarly, distance along the y-axis is called y-coordinate, or the distance to the x-axis is called the y-coordinate. Now we can point out, we can specify any point on the system using these two numbers, these two distances to the corresponding axis. So if it was this point, all we need are those two numbers, the distance along this axis and distance along this axis, to find this particular point. And we typically demonstrate that point, write it down to say x coordinate first and y coordinate second in brackets. So if this was point A, then the coordinates of this are x and y, with x being the first and y being the second, separated by a comma. Now let's call this origin as O. All right. So our next goal is to calculate the distance AO. How do we think about this AO? Let's imagine this right triangle right here. This is the hypotenuse. AO is the hypotenuse of this right triangle. So using the Pythagoras theorem, we can apply this x and this y to calculate the distance AO. So distance AO is the square root of this distance x squared plus this distance y squared. So this is x and this is y. So x squared plus y squared is the distance of point A to the origin. All right. Now, how do we calculate distance between any two points in there? So let's imagine a point here, and how do we calculate this distance? Let me show you. Now, I have 2 points on this x, y coordinate system, point A and point B. A is x1, y1 and B is x2, y2. And our goal is to find the distance A to B. Now, what we need to think about is a right triangle like this. Now, if we had this distance and this distance, we could apply the Pythagoras theorem here. How do we get this distance? Now, we need to look at the x coordinates here. All right. We know that this distance is x1 and this distance all the way till here is x2. That's the very definition of this x1 and x2. So this distance between these 2 points A and B along the x-axis, parallel to this x-axis, happens to be this distance, because this forms a rectangle with opposite sides being equal. This length is this length, this length is this length. These are all 90 degrees. So this distance right here is x2 minus x1. All right, so let's write that down, x2 minus x1. All right, so this distance is x2 minus x1. Now, similarly, we can imagine this distance to be y2 minus y1. y2 minus y1. What is the reason? This point is this much is y2 and this till this origin, I'm sorry, and till here is y1, and this distance is y2 minus y1. Now, how do we apply the Pythagoras theorem here? What we can do, AB is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So that is the distance formula right here, is that the distance between any 2 points in an xy coordinate system can be calculated as the difference of the x coordinate squared plus difference of the y coordinate squared is the square of the distance of the 2 points, or you can apply square root to find the actual distance. So AB is equal to x2 minus x1 squared plus y2 minus y1 squared. Now, I want to demonstrate how this formula would work if the line was to cut across multiple quadrants. So this is the same xy coordinate system, and you can see the point A is in a different quadrant than point B. The x coordinate here should be x2, y2. The xy coordinate here is x2, y2. Both of them would be positive, because x is positive here, y is positive here, and both of them would be negative here, x1, y1. Both of them are expected to be negative here. All right. Now, how do we calculate this distance? Now, this distance AB would be equal to this distance PB squared plus this distance PA squared, square root of the entire thing. Now, what is PB? Is equal to PM plus MB. All right. Now, you can see that this distance till here, let me use a different color. All right. So this distance would be the x-axis of this point, x2. This distance would be x1 right here. All right. So this PB would be this entire length combined, which still works out to be x2 minus x1, because this x1 was negative, so this subtraction would work out to be an addition of these two numbers. So the formula is similarly, let's look at the y-axis. It would work out the same way. y2 minus y1 would end up being the sum of this entire length. All right. So the formula still holds good. AB is equal to square root of x2 minus x1 whole squared plus y2 minus y1 whole squared, which is x2 minus x1, this entire distance, and this y2 minus y1, this entire distance. I just want to point out one more key element for you to know, that if, let's say, we thought this A to be here and B to be here, alright, so if we reverse this line, the distance doesn't change, it is still the same line. You see, we are squaring the term here. So if this was negative, positive, it doesn't matter. Ultimately, you will get a positive number because you are applying a square here. So if it was x2 minus x1 or x1 minus x2, it doesn't matter. You will ultimately get the same distance. So it doesn't matter which way we subtract. All that is going to happen is that it will become a square and it will become a positive number, and you will get the same distance whichever way you measure the distance from here to here or here to here. There you have it. This is the distance formula. Thank you for watching.